The floor is here for you, Rob. Go right ahead.
All right, how's everybody doing today? We got 16 people.
So they will not be able to see and hear you, Rob, or they can hear you, but you can't hear them.
Okay, that works. All right, I'm gonna share my screen here. We're gonna go over our wind uplift. All right, so this is the Wasusau wind uplift for roof deck pavers. I'm gonna skip through some of this stuff. What we're gonna do is we're gonna be discussing how wind affects building rooftops, discuss roof deck design, restraint options, and then roof deck requirements. Kind of the goal of this is kind of to examine the effects of wind velocity on a building's roof, considering design, location, and parapet height. Basically learn about the system itself and how it can help you when you're dealing with high wind pressures. Why are we talking about this? Wind is becoming more prevalent throughout the United States and into Canada. It kind of started off in the hurricane zones. Now it's working its way Midwest into New York. And we've also been dealing with a handful of jobs in Canada. And if you're not putting the right type of product on the roof deck, you might end up with a situation like this where the wind uplift actually will take what you have installed on the roof deck and kind of throw it all over the place. Couple important things to know: that just because you have high wind speeds doesn't mean that you're going to need a lockdown system, and vice versa. Just because you have low wind speeds, you're not going. It means that you doesn't mean that you will have to have or won't have to have a lockdown system. The highest pressures that you're going to see are going to be typically in the corners and along the parapet wall. And from here, I don't know if you can see my mouse, but kind of in the corner here, if the wind's coming from this direction, this area is going to see to about 2.5 to 3 times more uplift pressure than the middle of the deck. And then these parapet walls right along the corner here from the wind direction side, we'll see anywhere between 1.5 to 2 times what the field will see. Going over a couple of the building codes, I won't get into this in detail, but for a ballasted paver, it needs to hit at least 22 pounds per square foot. Your typical 2 foot by 2 foot by 2 inch thick concrete paver is going to be 24 pounds a square foot. So using a 2 by 2 at 2 inches thick, you'd be looking at 2.5 pounds, or excuse me, 24 pounds per square foot. I've got here shown Florida where it has the different wind speeds maps, and then based on your risk category, you can kind of see how that changes. So you've got 115 mile an hour right through here to 120 all the way down to 105 based on your risk category. And we can get information for Canada's wind speeds if needed. This kind of shows too a little bit how Florida, it really started off in Florida and then it moved into the Gulf and into Texas, and now it's kind of spread throughout the entire country. You got places in the Midwest here that are experiencing upwards of 115 mile per hour winds. And then if you look up here on the East Coast, you're at about 140 mile an hour winds. This is a little video to kind of show So that kind of goes over a little bit on what wind actually does and how it affects the pavers on a roof deck. So if we're looking at this, typically you don't start looking at wind until you hit 33 feet above ground. So typically after your third story, that's when you're going to start looking at wind and what it can do. And the reason that I had mentioned, just because you have high wind doesn't mean you all necessarily have to have a lockdown system, or if you have low wind, you don't, is wind kind of plays off the buildings, which is why when you do a wind engineered study, they actually look at all the buildings surrounding your particular project. So if you have a Venturi effect and you kind of get like that wind tunnel effect and you've got your building kind of sitting at the end, even though you might have a low wind area, you might experience some high winds sitting on this roof deck. Whereas if you are sitting on this building, the wind uplift pressures might not hit that roof deck as hard as it would the paver or the building in front of it. This kind of goes over what I was talking about earlier with parapet wall height. So if you don't have a very high parapet, you're going to experience a lot of higher wind uplift pressures throughout the majority of the deck, going almost all the way, you know, you're looking at about 70% of the roof deck. Whereas if you had a higher parapet wall, all of these pavers could actually be installed without having to do a lockdown system. And then you would just have to do a lockdown system here in the corner and then throughout this side of the building. Typically what we would recommend is that you have the building actually wind engineered studied. And what they're going to do is they're going to take the drawings of the project that you're working on, along with all of the surrounding buildings that you kind of see here. And then what they'll do is they'll actually create a mini mock-up of the city. They'll put in all of the pressure cords, so they'll know exactly where your wind pressures are hitting for cladding and for on the roof deck. So what they'll do is if they know that the majority of the wind is coming from this direction, they'll actually set this mock-up in that direction and then allow the wind to push, and then we'll get the pressures on the roof deck. Once they do that, they'll send you back a report that'll look something like this. So as you can kind of see, the wind kind of hit this thing on a couple different areas. So over here in the corner of the building and the roof deck, you got 85 pounds to 95 pounds of uplift. So if you're dealing with a product that's 24 pounds a square foot, essentially what this is saying with this wind uplift is that it'll take that paver, and there's a possibility that it could lift it up and actually fly it off the pedestal. And pretty much this whole deck, you're looking at over 60 pounds, 60 or 60 plus pounds a square foot. So if you had a 24 pound a foot paver, the majority of this deck, there's an opportunity where a paver could actually lift off and kind of flop out. So on a deck like this is something that we would recommend that you would have a lockdown system throughout the whole area. So what we did here at Wasusau is we did a lot of testing with our lockdown system. So the majority of this deck would actually just be a standard lockdown system. And then in certain areas like right here and right here, where you're experiencing 95 pounds a square foot of uplift pressure, we would require you to glue those particular pedestals down before you actually install the paver. So key features on our pavers, again, with our hidden lockdown system, you're actually going to be 2.5 inch to 2 3/4 inch thick. So you're actually going to be even heavier than 24 pounds a square foot. You're going to be looking at about 33 pounds a square foot. And then what we do is we actually take a saw cut into the paver, which allows you to slide the washer in. So here's an actual paver where you can actually see where that saw cut has been made. So then when you got a complete system, you don't actually see the lockdown itself. And it sits right within the paver itself. And then the reason that we have them slotted is that way, once you have the pavers installed, you could easily remove this bolt right here and then slide the washer back to basically remove a paver. And this kind of goes over what I was just showing you. So the washer sits right in there. The bolt gets screwed down into a puck. So you're looking at something like this. I'm gonna take that apart. Some of the testing that we did, we went to the wall of wind and we actually set up a mock-up and had the wall of wind hit it. And this is kind of showing what that mock-up will look like. They put these little core drills holes in there so we can kind of see where our wind uplift pressures are at. And then they hit it with the wall of wind. We've also done some in-house testing on our product. So this is an actual rafted system. And what we did here is we took 9 pavers, roughly 1,000 pounds. We used the hidden lockdown system and we were able to pick that whole system up, all connected, and they didn't break. Basically what that information gave us is we'll be able to have a rafted hidden lockdown system up to 90 pounds per square foot of uplift pressure. The system will be able to hold that. Once you start getting above 90 pounds of uplift pressure, that's when we will start gluing the pedestals down to your substrate. What we did for that is we actually went down to Miami and we did the Miami-Dade County Protocol TAS 114-95 Appendix D. That's basically the best test that anyone has come up with to kind of show how much wind uplift pressure a system can handle, and it's the leading test in the market. So what they do is they glue the pedestals down, they install a paver, and they pull, and every 30 seconds they raise, they put more pressure onto the system, and then it has to hold for 30 seconds, and they do that until we look at failure. In-house wise, for the pavers themselves, we do flexural, center load, and compressive tests to make sure that when you're purchasing pavers from Wasusau that you're getting the best pavers possible and that they meet our specifications on every job. Kind of looking at the series, we have 2 main series. We have a V series and we have an H series. The V series is going to be more of our customizable line. You're going to get a lot of different finishes. You're going to get a washed, ground and blasted, smooth, textured. We can do a lot of different things with this particular line. And then we also have our H series line where you'll have smooth, multicolor blends and blasted pavers. And this kind of goes over a ground and polish, a heavy blast, a 4-color blend, a slate or stone look, washed, a flat, blasted, and then ground and blasted. We also offer customization of the product. So if you're ever looking at a project where you need to have a certain color or you want certain aggregates shown in the job, all we would require is that you give us a Pantone or a Benjamin Moore color, and you can work with your outside sales rep as far as what kind of aggregates you want to see, and then we provide a sample at no cost. The lockdown system itself. So what you're going to do is you're going to want to set all of your pedestals or waffle reducers to make sure that they're all lined up, and then you're going to install row by row. So you'll put one row in, you'll slide the washer into the paver so it's nice and centered, and then you'll put the next one in, and then once you get that row done, you basically tighten the bolt to hold it down, and then you start the next row. This kind of goes over our pedestals. So we have a 6-inch, 11-inch, a 16-inch, and a 21-inch pedestal. And this kind of shows you how you would want to set up your pedestals, so that way when you get to installing the pavers, you're just installing them one right after the other, and there's not a lot of wait time. These are some different options that we have to help carry the block to kind of make it easier on the installer. And then maintenance of the paver, you're just looking at a power wash and then cleaning with a neutral cleaner. One thing I can do here. Just let me share. So if you're looking at our hidden lockdown system, this is what the cut actually looks like. It's about 1 1/8 inches from the bottom. The cut itself is about 5/32. And with all of the testing that we've done, like I've mentioned before, if you glue the paver or the pedestal to the substrate, you're looking at being able to withstand uplift pressures of over 240 pounds. And then anything under 90 will be just a rafted test. So here's some of the actual test documents. So for this particular installation, we use the Suprema membrane. And when they pulled on these tests, it shows a passing pressure of 540 pounds per square foot. And then per the Miami-Dade test, with a safety factor of 2 to 1, we're able to say that that particular system can withstand 270 pounds per square foot. And then I can show you here. So this is the Wasa tile rafted test. So again, we installed 9 pavers and we picked them up. And what we did is they had to stay rafted and without failure for 10 seconds. The reason that we did that for the test is typical wind speed is a 3-second gust. So we wanted to make sure that we were 3 times that. So it will be able to handle any type of situation that will show up on a building's roof deck. With that, and using the same kind of calculations as the Miami-Dade test, basically shows that with a safety factor of 2 to 1, a rafted system can be withheld up to about 125 pounds per square foot. But we're recommending anything over 90 be glued down. I kind of went over a lot of information. Is there any questions? Let's see here. So one of the questions is there a typical parapet height? There is not. Some building codes require a certain parapet height, but we work with architects and designers all the time on what kind of parapet height they're looking at and how we can help them. And a lot of the times you might get wind that'll hit a building and they have a very low parapet. They might be able to extend that parapet to the point where instead of a rafted system, you might be able to go with a standard system. It all depends on how that wind engineered study goes. One thing I can go over quick just is the parts and pieces of the particular system. So this is what we call a puck. And this is the terra stand top. So all you're doing is taking the puck and then screwing it into the top. You screw it all the way up so it kind of looks like that. And then you take a terra tab, you put that on top of the terra stand top. And then what that does is that basically helps you with your paver spacing. So that way you know exactly, you keep a level spacing throughout the entire installation. And then you've got your washer and your bolt. And then that just screws into the puck. When you're installing this kind of installation, you're going to need a torque wrench, and you're basically installing the bolt to about 2 foot-pounds of pressure. And that's all you'll need to make sure that the system is fully adhered and locked down. All right, so one of the questions that came up was, did you try the freeze thaw on that? So all of our pavers pass the freeze thaw test, and we do have multiple samples going through another freeze thaw with the curve cut. And we've actually been doing in-house testing and out-of-house testing with that. So with the out-of-house testing on a freeze thaw, you use a saline solution, which basically prevents the water from like completely freezing really fast. We're actually doing in-house testing, which there isn't an ASTM standard for, where we're actually not using a saline solution because we really want to push this to the limit to see what it does. All of the information that we've been getting back from our test lab and the outside test labs that we have working on this, everything has been good so far. Another question that came up for budget purposes, what's the cost per square foot installed? We're currently working, this is a new system that we've been testing for the last couple of years. We just came out to market with this year, and we're working with installers on that particular question. As far as your material, US wise, US dollar wise, you can get a paver for $4.10 a square foot, and the hidden lockdown system upcharge is $7 a square foot. And that includes your washer, your puck, and your bolt, and the kerfing of the paver itself. As far as the actual installed price, we'll probably know more of that, I'd say within the next couple of months, because like I said, we've been working with installers. We currently have one job that's being installed, and we have 3 more in-house, and we have another 4 or 5 coming in the next couple of weeks. And we actually have planned where we're going to be working with the installer to kind of see what we come up with and how much slower the install goes. We do have information on our website with a link to kind of show the installation. It's not that much slower of an install versus a standard installation. What else we got? Go down. Gravel ballast.
Gravel
That's just-
ballast is basically without any pavers, it's just rock and it's holding down what you can't use.
Yeah, one question came up with the gravel ballast. It wouldn't be used with rocks. It would have to be an actual paver. So another good question that came up is, how is the system designed to accommodate the roof slope? The actual pedestal itself will accommodate 5/8 per foot.
Yep.
So with that, I took a pedestal and we cut it really short. So you can kind of see that it's rounded here. So when you put the bottom of the core on there, you'll actually be able to kind of set your levelness. Like I said, it'll accommodate up to 5/8 inch slope per foot. And this particular system has been around for a long time. So the only real change to our pedestal is the addition of the puck, the washer, and the bolt. Otherwise, everything else is the same. What I can do is let me get on here. I'll jump on quick and I'll show you the video of the actual installation.
So when you share the video, just make sure you hit that share sound button in the bottom left, okay?
Okay. Where's the video?
Are you under hidden lockdown?
Yeah. All right, give me 1 second here. All right, looks like I'm having a little bit of technical difficulties getting the video loaded. I don't think they put the video up. All right, I'll have to find the video and I can send it off to anyone that would like it.
Yeah, we can get you a list of the attendees as well for you, Rob, too.
Okay. Are there any other questions on the hidden lockdown system?
Alrighty then. Well, if we're gonna have no more questions here, Rob, we can just wrap it up here. And I just wanted to thank everyone for coming to the seminar here today. There are a couple, I think, that are still going on if you wanted to pop into those ones as well. And I just wanted to say thank you again, Rob, for your presentation there as well. Okay.
All right, thank you guys.
Thank you, everyone.